Okay, welcome to the next lesson in our series, in our electricity lessons on the AQA GCSE physics specifications. Okay, right, we're going to be looking at potential difference, or voltage and resistance. Okay, so the equation we're going to be looking at is this one here. So V stands for potential difference, voltage, I stands for current, as we've looked if you remember from our previous video, where we looked at current is equal to Q divided by T, so it's the rate of flow of charge. That's measured in amps. So capital A. Voltage is measured in volts. And then this term here, a capital R stands for resistance, and its units are ohms, and it is this symbol here. Okay? So the triangle equivalent would be this, so the V on the top, and I would have my I times R on the bottom there. So if I wanted to work out current, I cover up my I have V divided by R. If I want to work out my R, it is V divided by I. If I want to work out my voltage, it is I times R, current times resistance. Okay? So let's do some practice. I'll just do one example because hopefully you're really confident in using these triangles. So if I want to work out current, so current is what I want to find out. And I'm given the voltage is 100 volts, and the resistance is 20 ohms. Current I is V divided by R, so I is V over R, which is 100 over 20, so that is 5 amps. Okay? Something as simple as that. Now, in exam questions, sometimes, let me draw just a simple series circuit. Here's my external resistor. I'm given an ammeter reading of 2 amps. This is 6 volts across there. And I'm assuming my voltmeter reading also measures 6 volts. How am I going to work out the resistance of this resistor here? Well, I cover up my R. It's V divided by I, so R is V divided by I, which is 6 divided by 2, so that's 3 ohms. Okay? Now the thing in physics, that's different to maths. There are circuits like this that you've got to interpret. Okay, so you've got to take the numbers from the circuit diagram and apply it to a mathematical equation, okay, like this. So, please do lots and lots of practice. There are plenty of exam papers with questions like this, okay? But, before I end the video, I want to just talk about what is voltage, okay? So let me just write, I'll make V the subject, it is I times R. Well, it's a measure of how much current, okay, is passing through a resistor, okay? And if we've got a large lamp that requires 6 volts, okay, and the resistance is 1 ohm, okay, then this will have to be 6 amps, okay? And obviously the voltage is dependent on these two terms, so I can have a high resistance, and if I've got something that's got high resistance, the current is going to decrease, okay? And vice versa, because resistance and current are indirectly proportional, okay, according to this equation. But if I increase any of these terms, I'm going to require a large voltage, okay? And that means I need an extra push, which makes sense, because if I now increase my resistance to, I don't know, let's say it's 20 ohms, okay, 20 ohms, but only 1 amp is passing through it, okay, that means I need a lot more voltage, notice this time, to pass that 1 current per second, or that 1 coulomb per second through a 20 ohm resistor. Okay, so what I want you to get from this equation is the relationship between resistance and voltage, that they are proportional. If we have a higher resistance, I need a higher voltage. Also, now let's say, okay, it takes 20 volts to pass current through this 20 ohm resistor. If I now double my battery power, okay, so now I've got 40 volts, this time it's still a 20 ohm resistor, but I've now got 2 amps passing through because I've doubled the power, so I'm pushing twice as many electrons through the circuit, through that resistor, okay, and so on. Hopefully that's helpful, and that is the end of the lesson: potential difference and resistance.